Welcome back once again. This is Dave Does Math at Home. We are diving directly into section 4.2, logarithmic functions. Without wasting any time, we're going to start with the fundamental question, what is a logarithm? And the answer to that is, a logarithm is an inverse exponent. So, exponents work by repeated multiplication. If you have something like 3 to the 4th, we'll get 81 because this is 3 times 3 times 3 times 3. Logarithms are going to do that process but backwards. You can think about them as repeated division if you like. It's a very interesting paradigm. It's not going to be super useful for what we're doing, but if it's useful for you, go for it and let me know. The log version of this expression is going to look like log base 3. Log is for logarithm. 3 is the base. Log base 3 of 81 equals 4. Because log base 3 of 81 means what exponent can I put onto 3 to get 81? That's what this expression as a question is asking. What exponent can you put on top of 3 to get 81? And the answer there is 4. 4 is the exponent you can put on top of 3 to get 81. So that's what these means. That's how we're going to use them. We're going to go through a couple more examples of logarithms and their connection with exponentials. And then we're going to talk about logarithmic functions. So let's just go through a bunch real quick. Let's do the log base 2 of 64. Let's do the log base 4 of 64. That'll be a good contrast. Let's do the log base 2, 256. And the log base 3, 27. And what else should we do that's weird? Oh, let's start with these 4. And then we can do the weird stuff in a second. This question is asking, what exponent can you put on top of 2 to get 64? So 2 to what power gives you 64? The answer is 6. 6 2's multiplied together will give you a 64. You can kind of count up by 2's. If you're a programmer, you should probably know this. You should probably know all of the powers of 2 if you're a programmer. If you're not a programmer, you can kind of count up by 2's. So 2, 4, 8, 16, 32. One more gets you to 64. So 6 2's will get you to 64. So this is 6. Log base 4 of 64 is asking a similar question. What exponent can I put on top of 4 to get 64? And this one, if you're following along at home, you can count by 4's if you like. 4 times 4 is 16. That's 2 4's. 16 times 4 is 64. So that will get us there in 3 steps. Again, this one's for my programmers out there. What power of 2 gets you to 256? This is a very important number. 256 is 1 full byte of information with 8 bits, because this is 2 to the 8th. And then this one right here is same thing. 3 to what power gets you 27? And I hope we all recognize that 3 cubed will give you 27. This is basic logarithms. Now we're going to talk about weird logarithms. Let's talk about log base 2 of 1/8 and the log base 5 of 1/5. And let's also talk about the log base 36 of 6. And let's talk about the log base 4. No, let's talk about the log base. Let's talk about the log base 27 of 3. Once again, I recommend starting these problems in the exact same way we started the other problems. If you're answering a question about logs, you have to ask yourself, what does the log mean? And the log always means, what exponent can I put on top of 2 to get 1/8? And this is going to be a little harder than the last set of problems because you're going to need 2 pieces. First, you need to be able to turn a 2 into an 8 using an exponent. And that's fairly straightforward. You can turn a 2 into an 8 using 3. That's not so bad. The second part is, you have to flip that 8 upside down. Because we don't just want 8, we want 1/8. We have to make it a fraction. We need the reciprocal. And we need to get the reciprocal using an exponent. You can't just say division. You can't say like division 3 is an exponent. There has to be a numerical exponent that will transform this 8 into a 1/8. And the numerical exponent that does that is negative. 2 to the negative third means 1 over 2 cubed. Remember, negative exponents mean fractions. So that's a thing that can come up in logarithms. You take the logarithm of a fraction, you probably get a negative number. This one is going to work very similar. We probably should have started with this one, honestly, because it's similar but simpler. This means, what exponent can I put on top of 5 to get 1/5? And here we don't actually have to change the value. Like here we got a 5, we want to turn it into a 5, that's peanuts. It's already a 5. We don't have to change anything. But we do have to flip it upside down, so you need that negative 1 in there. So this logarithm is negative 3, this logarithm is negative 1. And this is one flavor of weirdness that you can encounter when doing these logarithms. This is the other flavor. And again, we're going to start it in the exact same way. What exponent can I put on 36 to end up with 6? And it's very tempting here to say like 1/6, because we're thinking about multiplication, and 36 times 1/6 would give you 6. But we can't use multiplication here. It has to be an exponent. It has to be something we can do to the number 36 as an exponent that will yield the number 6 as output. And the thing that you can do to 36 to give you a 6 is take the square root. The square root of 36 is 6. And the square root is an exponent of 1/2. Fractional exponents mean roots. Those are the two big weirdnesses you have to keep in mind when you're doing logarithms. Negative exponents mean fractional outcomes. Fractional exponents mean square roots. So, The answer here is going to be 1/2. This one we need to set up in pretty much the same way. We're going to look at 27 to some power needs to give us 3. And we just, in the last set of examples, we just did a 3 cubed equals 27 example. So we should, I think, know that the cube root of 27 is 3. So all we need to do here is express the cube root as an exponent, and that exponent is 1/3. So, logarithms mean what exponent can I put onto the base to get the argument. That's the fancy name for the number in the parentheses is the argument. It's I think it comes from programming, from coding. When you call a function, you have to give it the argument. Yeah. What exponent can I put on top of the base to get the argument? That's what logarithms are asking. This has been a quick, but I hope thorough introduction to logarithms. I'm going to cut this video here so that I can start talking about how to graph logarithms in the next one, so stay tuned.